exceptionalism. But before I dive into this, I thought it'd be fun just to show you some of the latest images being released from both the Hubble Space Telescope and the James Webb Space Telescope, and how this is giving us more evidence for creation as taught in the pages of the Bible. This got released just Friday, just this past Friday. The Hubble Space Telescope is still pumping out really spectacular images. This is the object known as HARP Mador 417-391. Don't they come up with these amazing names? But it was Chip Arp, Halton Arp, who back about 40 years ago produced a catalog of peculiar galaxies. And then a young astronomer, well, he's not that young, he's my age, Barry Mador, teamed up with Chip Arp years ago to develop an update of catalog of peculiar galaxies. And this particular object is the one to the right in the image that you're seeing there. It's actually two galaxies, two spiral galaxies that are colliding with one another. And as they collided, they produce this incredible ring of stars and spiral arms that radiate out from the two cores of the galaxies. So when you look at the two galaxies, what you see that are left over are the cores of the galaxies, but their spiral arms got strung out into this amazing circle. And I did research with Halton Arp when I was at Caltech. He's passed on, but Chip and I did some work together on measuring the distances to quasars, and also Barry Mador was a graduate student with me at the University of Toronto, and he's still active doing astronomical research. His particular interest is on the cosmic expansion rate and the age of the universe. This object, to give you an idea of just how powerful the Hubble Space Telescope is, these galaxies are 670 million light years away. And then also a week ago, 2 weeks ago, the Hubble Space Telescope released this image of a spiral galaxy that is seen exactly edge on. So this is the new general catalog, NGC 4634. This galaxy is quite a bit closer to us, 70 million light years away, but it is seen exactly edge on. And you can see that it's a much more disturbed galaxy than our Milky Way galaxy. And this is an image taken with a filter at yellow wavelengths, and they did the same thing at the blue wavelengths, where you get to see this one emphasizes the younger stars, this one emphasizes the older stars, and you can see that they fit in a way that is quite predictable for spiral galaxies. But yeah, exactly edge on. We do see a few of these galaxies. And then 2 weeks ago, a new image from the James Webb Space Telescope was released. And here again, they did a side-by-side image. And the James Webb Space Telescope is a space infrared telescope. Now, telescopes on the ground can see the very near infrared, that part of the spectrum that is quite close to the red part, but only a space telescope can see the mid or far infrared. And this is a comparison of the previous best image taken by a space infrared telescope, the Spitzer telescope, side by side with the James Webb Space Telescope. And this is of a core part of the what's called the WLM dwarf galaxy. This is a galaxy 3 million light years away. It's on the edge of the local group of galaxies in which our Milky Way galaxy exists. And on the left, you have the previous best infrared image of this portion of the WLM galaxy. And on the right, you have the James Webb Space Telescope. And you can just see how much more superior the image is on the right. And what you're seeing there are the stars and nebulae within the WLM galaxy, but you're also seeing really distant background galaxies. So you can see, like there's one to the upper left, a spiral galaxy, and you can see several down towards the bottom and off to the right. Those are more distant galaxies, but this is a tiny section of the WLM galaxy, and this was taken by the European Southern Observatory. This shows the entirety of the WLM dwarf galaxy, and the image you saw previously, that's outlined in that little yellow box there. So that yellow box basically shows you what you're looking at in this previous image. And so here we see what the whole dwarf galaxy looks like. Now, probably the most popular deep space image that you see is of the Eagle Nebula, otherwise known as M16. It's 6,700 light years away. It's in the constellation Serpens. You can actually see this with a good pair of binoculars, although all it'll look like is a tiny little fuzzball. This is taken from the Hubble Space Telescope. It's in the Sagittarius spiral arm. I mean, right now we're in between two spiral arms, the Perseus spiral arm and the Sagittarius spiral arm. And so this nebula is in the Sagittarius spiral arm. And this shows the entirety of the Eagle Nebula. And this has been the subject of a lot of detailed imaging by the Hubble Space Telescope. And so this shows you the interior, the little central part of the Eagle Nebula, and all those little boxes that you see there are places where they've used the Hubble Space Telescope to take deep images. And the most famous one of all is that one that you see towards the bottom center, that little not quite a box image. And this is known as the Pillars of Creation. You see it on t-shirts, you see it on coffee mugs, people have hung it on walls. It's the most popular image ever taken by the Hubble Space Telescope. And they call it Pillars of Creation because it's at the tip of these, what they call elephant trunks, that new stars are forming. So this is where, quote, star creation is taking place. And when I was at the University of Toronto, I took a week-long course from Carl Sagan. He was the one that was famous for saying the universe is all there is or was or ever will be. He was a lifelong atheist. But probably his second most famous quote is that we are all stardust. And that's another reason why they took the name of this, the Pillars of Creation. These are where stars are forming, and we're all made out of stardust. Well, not entirely. I mean, the Big Bang creation event during the first 4 minutes after the cosmic creation event takes the primordial hydrogen and makes helium. So a lot of what's in our bodies are hydrogen molecules, and most of those hydrogen molecules were there at the beginning of the universe. But everything heavier than helium was made in stars. And so all the potassium in your body, all the carbon, the nitrogen, oxygen in your body, the phosphorus in your body, that was all made in stars. And I remember taking this course from Carl Sagan, and he would make the comment, well, we're nothing but stardust, as if we humans are not exceptional at all. We're just simply a collection of stardust. We're no better off than the rocks on the face of or the pebbles on the beach. We're just a stardust. But what he overlooked, and this is something I studied after I got my doctoral degree and began to look in detail at the elements that actually compose our body and our planet Earth, and realize, yes, we're all made up of stardust, but we're composed of highly fine-tuned stardust. Is that it takes a certain variety of stars, just right stars forming just right in the vicinity of the emerging solar system and the emerging sun, to give us the elements in just the right abundance ratios so that we can live. And you'll see this explored in two of my books, Improbable Planet, which came out in 2016, and Design to the Core, which came out just a few months ago, where you actually can see an analysis I've made of all the elements in the periodic table. And what's interesting about those 92 elements, incidentally, when the Earth was formed, we had 94. We also had Neptunium and technetium and plutonium, but they decayed fairly quickly. So all we have today are the 92 elements that you see in your chemistry classroom posted on the wall. But of those 92 elements, the hydrogen we see is normative for the rest of our Milky Way galaxy. So is the helium, so is the magnesium, and so is the iron. So 4 out of those 92 elements, our planet Earth manifests in a way that we see that's typical of the rest of the stardust in our Milky Way galaxy and the universe as a whole. But if you look at those other 88 elements, our planet Earth has them in highly anomalous abundance ratios. I mean, to give you some examples, we have 60 times less sulfur than what we see in other rocky bodies of the universe and our Milky Way galaxy. We have 90 times as much aluminum, 60 times as much titanium. And when you get to some like the lead, the uranium, and the thorium, we have 630 times as much thorium, 340 times as much uranium. And what's interesting about these 88 elements, they are anomalous from, say, a factor of 3 to a factor of 630 times compared to what we see elsewhere in the rest of our Milky Way galaxy. But they're all at the just right level so that we humans can exist and that we humans can launch and sustain global civilization. 22 of those 88 elements are crucial for us to live. There are 22 elements in the human body. Well, there's more than that, but there are 22 that are essential for you to be alive. So, for example, you've got thorium in your body, but you don't need that. And so you can do quite fine if you didn't have any thorium at all. But the reason why there is thorium in your body is because there's so much thorium in the crust of the Earth. When you eat your vegetables, you're eating a little bit of thorium as well. But it's not essential. But 22 of the 88 elements are essential. And so, that's 1/4 of all the elements that we see in our periodic table. And we refer to them, at reasons to believe, we refer to them as essential poisons or vital poisons, in the sense that if you've got too little in your body, you will die. If you've got too much in your body, you will die. Or to put it another way, if you've got too little in the crust of the Earth, we'll all die. If you've got too much in the crust of the Earth, we'll all die. I'll give you an example you're probably familiar with. We all know that too much arsenic in your body is a bad thing. I mean, after all, there's all these novels where someone will put extra arsenic in the food that people eat and they wind up dying. But the truth is, you do need arsenic to be alive. Now, you don't need much. About 1 part per million is quite adequate. But we do need a tiny amount. There's actually proteins in our body that are built on arsenic. And if you don't have adequate arsenic in your diet, you won't have those proteins and you'll die. But arsenic very easily substitutes for carbon. So if you got too much arsenic in your body, the body winds up making things that inevitably will kill you. But the arsenic is at the exact right level. That's true of copper, that's true of zinc. There are 22 elements, selenium and others, chromium. And I think this is important when we talk about the craze that we have here in America for taking dietary supplements. I mean, you can go to a health store and you can get chromium supplements. You can get selenium supplements. But I would advise you, be careful how much you take. Too much selenium is bad for your health. And likewise, too much chromium is bad for your health. But if you're chromium deficient, you want to be taking some extra chromium. If you're selenium deficient, you want to be taking extra. But if you have a normal diet, you'll get just the right amount of selenium and chromium you need. So yeah, pillars of creation. I love the fact that that title was put on that by NASA scientists who weren't even believers, because it's actually making a point. We need it to be just this way. Now, this is the most famous image. This is the one you see on t-shirts, on coffee mugs, on plaques on the wall at different schools and universities. But it's not the best image taken by the Hubble Space Telescope. In 2014, they did a long exposure and came up with this image. So quite a bit more detail, as you can see, in those pillars of creation. And this particular kind of looks like a hand being stretched out. And so again, this is now making its way onto t-shirts and coffee mugs. But what happened a couple of months ago, about a month ago, is the James Webb Space Telescope looked at this same set of pillars of creation and came up with this image. Now keep in mind, what you're seeing here is an image at visual wavelengths, the wavelengths that our eyes pull in. The James Webb Space Telescope pulls in wavelengths at infrared wavelengths. And the infrared, you're going to see more of the dust as opposed to the light that you get from the stars. So we see here in the pillars of creation, you see stars that are already formed and stars that are in the process of forming. And how stars form, and they do form, you see those elephant trunks there? What's happening is cold gas and dust is being gravitationally pushed towards the tip of that elephant trunk, where gravity now begins to collapse that cold gas and dust, and eventually that forms a new star. And typically it takes anywhere from, say, 100,000 years to several million years for a big clump of cold gas and dust to collapse under its own gravity and form a star. But in this particular image from the James Webb Space Telescope, you're actually seeing a lot of the details of the dust as being compressed. Now, parts of this image, the dust is being expanded, which means in that particular part of the nebula, a star will not form. But because of the chaotic motions of matter within that area, there are parts of it where gas and dust are being compressed, and parts where gas and dust are being expanded away. In this particular case, they wanted to get a detailed image of those regions where the gas and dust is being compressed so they can learn more about the details of star formation. And in the case of the Hubble Space Telescope, you're basically seeing three predominant elephant trunks. But as we move into what you see with the James Webb Space Telescope, you not only see those three predominant elephant trunks, you can see a whole bunch beginning to form in the bottom part of the image. So you look at the bottom part, you see several of these much smaller elephant trunks that are beginning to form, and that's the area that astronomers are studying in detail. Not so much the famous pillars of creation, but the new ones that they're able to see because of the higher resolution and detail we're getting from the James Webb Space Telescope. And just a week ago, they released this image from the James Webb Space Telescope, where you have the most detailed one taken. I'm showing you this image at 2.4 megapixels. They actually have released one at 123 megapixels. And I'd love to show you all the details. It's a spectacular image. But you know, these cameras are not able to show resolution at that level. This is about the best that I can show you. But I'm mentioning this because you can go on the NASA website and actually pull up the original image, 123 megapixels. And I encourage you to do that. It's a mind blower, the details that you can see in those smaller elephant trunks to the bottom left. And some of you may have been aware of this image that was released about a month ago of the two top elephant trunks. And here you can see the movement of the gas and dust in far more detail. They took this at a little farther into the infrared spectrum. And so this actually shows you a lot more details on the dust that's surrounding the pillars of creation. Now, in addition, the James Webb Space Telescope was used to look at a completely different part of our Milky Way galaxy, and this is looking at what they call a protostar. And so in these pillars of creation, we got stars that are forming. A protostar is an object that's already beginning to radiate light. It's not in the process of collapsing to become a star. It actually is what we call a protostar, which means that the gravity has compressed the gas and dust to such a point that it's heated up and is now radiating light as a star. And that happens when you actually compress any body, it gets warmer and warmer. It's the thermodynamic principle in which our car engines run. When the piston chamber compresses, the temperature goes up. When the piston chamber expands, the temperature goes down. And so even before nuclear burning kicks in, stars will actually shine. Well, we call them a protostar because the nuclear furnace has not yet been turned on. But the star has been compressed enough where from gravitational energy alone, we can see the star. And so this is the protostar with the very picturesque name L1527. And you're beginning to see how the star is formed. As the star is forming, it's now radiating fairly bright light. And this light is actually ionizing gas. And so what you have is cold gas and dust compressing in from the left and the right. And the radiation from the star is illuminating the gas and dust at the top and the bottom. However, if you look carefully at the center, and this is what really caught the attention of astronomers. I'm going to actually zoom in a little bit so that you can actually see what's happening in the center here. And if you look carefully at the image, you can see a horizontal dark line and right where the star is. And what that horizontal dark line is a protoplanetary disk. It's a disk surrounding the star composed of dust and pebbles and rocks and of planetesimals, bodies about the size of asteroids, and that's what's blocking out the light of the star. We call it a protoplanetary disk because we realize as this protostar begins to continue to develop, all that dust and pebbles and rocks and asteroids and comets that are there will coalesce to become planets. And this is one of the objectives of the James Webb Space Telescope, is not only to understand star formation in far greater detail than we ever had before, but especially to understand planet formation. And so the James Webb Space Telescope is going to be looking at literally dozens of protostars where we can see this disk of dark material surrounding the star, and looking at that with dozens of different objects to actually determine in detail how do planets form, and with the idea of addressing the question, why are the planets in our solar system so different from the planets that we see in all the other 3,600 planetary systems we observe? So we know there's something extraordinarily special about our solar system. I wrote 2 chapters in that in the book Designed to the Core. Anyway, this is all basically background to this new series I want to launch on a human exceptionalism. And I'll give you a little more background. In other words, I'm basically making a point. Star formation and planet formation must happen in just the right way, even for us humans to exist here. And so to get these elements in the anomalous abundance as they are, we have to form at just the right time and the right place relative to neutron stars that are merging together to make black holes. When you look at the periodic table, half of the elements that are heavier than iron come from neutron star merging events, where 2 neutron stars begin to orbit one another. You get 2 stars that are in a binary relationship, and both of them end up as neutron stars. And as they orbit one another, according to the theory of general relativity, their orbits shrink. And so the stars begin to orbit closer and closer together, and eventually they merge. And when they merge, the two stars, being more massive, become a black hole. But at the merger event, you get this huge, intense shower of neutrons. And a quarter of the elements in the periodic table, we call them rapid process elements. They're elements that can only form when you have a very fast-moving, dense shower of neutrons. It's basically neutrons that are impacting iron and building up elements heavier than iron. But as we look at those rapid process elements that we see here in the crust of the Earth, every one of them is at an extremely anomalous abundance level, which means we had the good fortune of forming either really close, or maybe we formed at a time when two of these events were happening. Neutron star merging events are quite rare. Astronomers have only seen it happen once with the new gravity wave telescopes. We know they're rare events, but in order to explain the elements we see in the crust of the Earth, the solar system must have formed. Not so close that the neutron star merging event would have destroyed the solar system, but close enough where we got enriched at just the right level. Well, again, moving into the series on human exceptionalism, I want to kind of put this in a context of a debate I had a few years ago when we had a conference, a Reasons to Believe conference in London, England. And I remember being contacted by the British radio and TV group called Premier Radio, Premier Television. And they said, can we have you do a debate with Peter Atkins? And Peter Atkins is an Oxford University chemist. And Fuzz was with me at the time and says, oh, I know Peter Atkins. I had to study his textbooks. I took chemistry a few years before Fuzz did, so I wasn't taking textbooks from Peter Atkins, but Fuzz indeed was. And so we got introduced to Peter Atkins, and Fuzz says, yeah, I had to study all your textbooks. Well, most people who have taken chemistry within the past 30 years likewise have had to study his textbooks. He's written 9 chemistry textbooks over the course of his life. But he's a member of the Humanist Association in Britain. He's been referred to as Britain's second most famous atheist, the most famous one being Richard Dawkins. He's considered to be the most second famous one. Anyway, we had a debate, and it was on Premier Radio, the show Unbelievable, and the debate lasted about an hour and 10 minutes, and it was in the last 10 minutes where the moderator of the debate, Justin Brierley, turned to me and said, Hugh, we've been talking for a whole hour, and we've heard from Peter that you have to base your belief on hard scientific evidence. And you've shared some of the hard scientific evidence for why you're a Christian. But what would it take for you as a Christian in terms of scientific evidence to force you to abandon your Christian faith? And I said, well, yes, there are things. And so I named these 3. I said, if it became beyond any shadow of scientific doubt that our universe did not have a beginning, that it was eternal, did not come from a creation event, that to me would be catastrophic to my Christian faith. Likewise, if we were to have incontrovertible scientific proof that we human beings only differ by degree and not in any kind of fundamental kind with the animals, that too would be catastrophic to my Christian faith. Or if we could prove scientifically that Jesus did not rise bodily from the dead, that would be catastrophic to my Christian faith. And Justin jumped in and said, well, that's enough, because I had more, but he says, that's sufficient. And then he turned to Peter Atkins and said, okay, how about you, Peter? What would it take scientifically for you to abandon your atheism and become a believer in God and become a Christian just like Hugh. And he sat there for a minute and said, well, I think if Jesus were to appear bodily right in front of me just a few feet away, that would be powerful evidence that I've been wrong. But no, if that really did happen, I would conclude that I was having a delusional experience. And therefore, there was just something wrong with my brain at the time. And so Justin said, well, is there anything else? And he says, well, frankly, there's nothing that science could ever do to persuade me that God does indeed exist. And the irony of all that, for an entire hour, he was berating me, saying, you have to base your belief on scientific evidence. But it wouldn't happen. Now, what I've been noticing in looking at the latest theological literature is that it's not just atheists that are attacking the doctrine of human exceptionalism, it's theologians. And it's not just the liberal theologians, it's the conservative theologians. And as I've been engaging these conservative theologians, they're saying, well, we have to abandon this archaic doctrine of human exceptionalism because of the force of the scientific evidence. And the scientific evidence they're referring to is their perception of what they think has happened in genetics and paleontology, where they said, we now see that there's scientific evidence that we humans are not exceptional. We're the product of naturalistic evolution from a common ancestor. And so they've kind of bought into this idea that all life on planet Earth is naturalistically descended from a primitive bacterium that existed on the face of the Earth 3.8 billion years ago. Although I've run into some of them and said, well, no, I'm just simply agreeing with the scientists that all the primates are descended naturalistically from a common ancestor. So, yes, these three, I would argue, are pillars of creation. We've been talking about the pillars of creation, looking at the Eagle Nebula, but I would argue these are fundamental pillars of Christianity. And you actually see Paul, the Apostle Paul, referring to this in 1 Corinthians, where he says, if it actually can be proven that Jesus did not rise bodily from the dead, then we who are followers of Jesus Christ, we're to be pitied because we believed a lie and we're still stuck in our sins. And so he was the one 2,000 years ago who made the point that a critical pillar, a foundation of the Christian faith, is that Jesus indeed rose bodily from the dead. And if that didn't happen, then Christianity has been falsified. And so I would name these two others. But there's a reason why I chose these three when Justin Brierley, in my debate with Peter Atkins, asked me, Hugh, can you come up with some scientific proofs, evidences that have proven beyond any shadow of doubt would cause you to abandon your Christian faith? I chose these three because a converse proves a Christian faith. In other words, if we can demonstrate that there is an actual beginning to the universe, as described in the Bible describes the beginning of the universe as including not just all matter and energy, but all space and time. And this is what's unique to the biblical doctrine of creation, is that the Bible teaches that there's not just a beginning to matter and energy, but a beginning to space and time itself. So if we can use science to demonstrate that there's an actual beginning to matter, energy, space, and time, this establishes the Christian faith. Likewise, if we can demonstrate that we human beings are exceptional amongst all life on planet Earth, that we stand apart in many different exceptional ways, that would prove the Christian faith. Or if we can demonstrate that Jesus really did rise bodily from the dead, that again would establish the truth of the Christian faith. So that's why I picked these three. And I like to jump in to us human beings being exceptional. I see that I'm actually past my time, so I'm just going to quickly jump into a few passages that basically make the point of human exceptionalism. These are biblical declarations. God created mankind in his own image. In the image of God, he created them. Male and female, he created them. The Bible does not say this of anything other beings that he created. The angels are not created in the image of God. The plants and animals that share the planet with us are not created in the image of God. So right there in the very first page of the Bible, it's telling us that we human beings are exceptional, and that of all the creatures that God has created, we alone have upon us the image of God. Now, in the very next sentence, it says that God blessed human beings. Now, of all the animals that he created, all the plants he created, it's unique to human beings in Genesis 1 that we are personally blessed by God. As you read throughout the rest of the Bible, we have a blessing imposed upon us that we don't see in any other part of creation. The third point I will make is one that we discussed last week. We were talking about prayer. We are exceptional in that God has given us a mission that he has not given to the angels. He's not given any life form. He says to the humans that he created, be fruitful and increase in number, fill the earth and subdue it, rule over the fish in the sea and the birds in the sky, and over every living creature that moves on the ground. So we alone have been given a mandate to manage the resources of planet Earth for our benefit and the benefit of all their life. Okay, next week when we come back to this, we're going to go into detail about what the Bible declares about the image of God. What does the image of God mean? What does it mean that we've received a special blessing from God, a unique blessing? And what about this mandate that we have to be fruitful, increase in number, and subdue and rule over all the resources of a planet Earth? So next week we'll be getting into this particular list. But I'm going to stop there, and we'll take questions. And as usual, I'll take questions on any subject. It doesn't have to be what we've been talking about for the past half hour. And we'll alternate between people here and present and people participating virtually. It looks like we got a virtual question all set up.
Yes, we have one virtual from Susan Lamb. Paradoxes. Besides the fact that the universe has to be the size it is in order to have intelligent life, do you think that if we were able to actually see an edge to the universe, we feel boxed in and feel sort of paranoid about being boxed in?
Okay, that's a good question from Susan Lambeau. By the way, she's been a faithful follower of Reasons to Believe since the very first year this ministry's been launched. And she's with us every time we have a paradoxes class here. But good question. We know the universe has to be a precise mass and a precise size for life to exist. If the mass of the universe isn't extraordinarily fine-tuned to within about 1 part in a quadrillion, we would not have the essential elements for life to exist. We wouldn't have the carbon, the oxygen, the nitrogen, the phosphorus, the potassium, and all the other 22 elements we need for life to exist. So it must be at just right mass. It needs to be at just right size in order that the different particles that make up the massive components of the universe be sufficiently separated from one another that you could actually have stable orbits of a planet around a star where advanced life can exist. So you don't want the stars jammed too tightly together or the galaxies jammed too tightly together. And when that happens, you also wind up with radiation sources that are deadly for life, like supermassive black holes. On the other hand, you don't want the stars and galaxies too far apart, because if you got them too far apart, we're not going to get the needed abundance of these heavy elements that we've been talking about. So they need to be at the just right level. But Susan's question is, well, if that's the case, don't we would kind of feel boxed in? Well, it's a big box. I mean, the universe we see through telescopes basically takes you back to the cosmic creation event, because you look through a telescope, you're looking back in time. And therefore, we can only see out to 13.8 billion light years. But the universe is expanding, so the universe of today is much bigger than the universe we see through telescopes. And astronomers have calculated that at a minimum, it's 96 billion light years in diameter. So it's a big box. But the truth is, it's not really a box. There really isn't an edge to the universe. There isn't a center of the universe. The universe is 4 dimensions, length, width, height, and time. And when you're looking at a really big size scales, the time dimension behaves like a 4th space dimension. And so we now recognize that all the stars and galaxies, all the matter and energy is distributed along the 3-dimensional surface of the 4-dimensional expanding universe. And to give you an analogy, think of planet Earth. Planet Earth is a 3-dimensional body, but we humans live on the 2-dimensional surface of the 3-dimensional Earth. And as such, no human can say, I'm at the center of the Earth. I mean, in one sense, everybody is at the same distance relative to the center of the Earth. Nor can we say that there's an edge. If you keep moving along the surface of the universe, you're never going to find an edge. You're never going to be boxed in. And that, with the case of the universe, it could be a closed surface, or it could be an open surface like a parabola, or it could be a flat surface. But whatever, you don't have an edge. There is no edge. And, we can't point to the center. Now, in one sense, the universe has a center. The center of the universe is the point of origin, where all the matter and energy was compressed into an infinitesimal volume. Everything's been expanding from that. Everything stays on the surface. We're all equidistant from the center of the universe. And so when you ask an astronomer, where is the center of the universe? He would say, point any direction you want. That'll take you to the center of the universe. Again, the analogy you'd have here on Earth, where's the center of the Earth? No matter where you are on the Earth, all you got to do is point down, and that takes you to the center of the Earth. So, next question. Oh, we got one here. Thank you.
Since the entire universe is imagined and brought into being by God, aren't all species exceptional?
Okay, good point. Since the universe was created to make possible all life, isn't all life exceptional? I would agree with that. I mean, you're a biologist after all, and as a biologist, you look at life and you realize every life form is incredibly beautiful and intricate and complex in its designs. So I would agree with you. Every life form is exceptional. The angels are exceptional. The point I'm making in this series is that we humans are different by a wide margin, not just by degree, but by, different characteristics from all their life that exists. Yes, you could say that we humans are animals. We are. We're mammals. We're primates. So we share a lot in common with other life. I mean, 26% of our DNA is identical to daffodils. So we have a lot in common. But there's also things about us that are truly exceptional. And I just went through 3 Bible passages that basically say these are areas where we human beings stand completely apart from all their life on planet Earth, and not just all life on planet Earth, but from all life that God created. We're not like the angels. We're distinct from the angels. I mean, I've been in some churches where people had the belief that when you die, you become an angel. No, we're actually going to be looking at texts that make the point that we humans are distinct from the angels, and that we humans one day will be ruling over and teaching and instructing and judging the angels. The reason why? We are exceptional compared to the angels. Yes, they are more powerful than us at this particular point in time, but what's unique about us, and we'll get into this next week, is we are the receivers of God's grace. And so the frogs don't get grace from God like we do. The plants don't. We humans receive grace from God that delivers us from our state of sin and evil. This is something the angels don't experience. The angels, however, are given the privilege of watching the outworking of God's grace within us human beings. Anyway, that's subject matter for next week. Do we have another online question?
Okay, mic's on now. My apologies to Susan. The mic was off.
Oh, okay.
But Valerie asked, will observations with the James Webb Telescope result in astronomers greatly increasing the estimated amount of stars and galaxies in the universe?
Well, astronomers already have a good measure of the mass of the universe. And we also have a good measure of how much of that mass is in the forms of stars and galaxies. And if you want the details, that's in the 4th edition of the Crater in the Cosmos. So we know that number to, well, at least 3 decimal places, how much of the total mass of the universe is in stars and galaxies. What the James Webb Space Telescope will do for us is actually enable us to see more of those stars and galaxies. And when you ask an astronomer, well, how many galaxies are there in the universe? If you were to ask an astronomer, say, a decade ago, he would have said, well, maybe about 200 billion galaxies. Now they're saying 2 trillion galaxies. Now, it's not that the two numbers are discordant. When astronomers a decade ago were saying 200 billion galaxies, they were meaning 200 billion giant, large, and medium-sized galaxies, realizing we had no capacity to see dwarf galaxies any more distant than, say, the environs of the local group. And so they wouldn't count those galaxies. The James Webb Space Telescope is giving us the ability to count the smaller galaxies. So that's why we're beginning to see a larger number being posed here. And what the James Webb Space Telescope that is going to be used is to actually pin down for us what is the percentage of galaxies in the universe that are giant, large, medium-sized, large dwarf, and small dwarf galaxies. We've got some ideas, and I mentioned those in the Crater in the Cosmos 4th edition, but the James Webb Space Telescope is going to be able to pin that down with much greater precision, especially at the level of the smaller mass galaxies. Now, full disclosure here, it will not give us an accurate number for the small dwarf galaxies because the James Webb Space Telescope is not powerful enough to see those galaxies at great distances. So we're going to need a bigger telescope to actually get that right answer. Go ahead.
Since we're human beings and we live in what we call time and space, there's some examples in the Bible where Jesus was talking to the criminal on his side. He says, "Today you will be with me in paradise." John on the Isle of Patmos was caught up into heaven. I think Ezekiel was caught up into heaven. Paul went to the third heaven. Now, I know that we can't really know, but is heaven or this place, is it outside of time and space, or is it a place that we go to, or is it another dimension?
Okay, good questions. And it's definitely a place, because Jesus said, "I go to prepare a place for you." And it referred to the place with the thief on the cross that had repented. "You'll be with me today in paradise." And I like the fact that you cited the passage in Corinthians where Paul says, "I was taken up to the third heaven." And the word for heaven in Hebrew, the Shemayan, has 3 different definitions. The Hebrew word for heaven can refer to the troposphere where rain clouds form, or it could refer to the universe of stars and galaxies. That's the second heaven. The third heaven is that which is beyond our universe. So yes, it's a completely different space-time realm. And it may not even be dimensions of space and time. So that third heaven, that place where Jesus and the thief went, the place where the dead in Christ will go when they pass through their life here on earth, it's in a completely different realm than the universe. So you'll be taken beyond the universe into a different dimensional realm. Exactly what that dimensional realm is like, we don't know. But it is a place where you'll have fellowship with the creator of the universe at a far more intimate level than we do now. That's the wonder of dying as a Christian. We actually get to experience a more intimate relationship with our creator when we die than we have right here, and also with the rest of the dead in Christ. And we don't remain in a state of sleep forever. A time will come when we will awake. Well, while we're asleep in this realm beyond the universe, we will be able to be aware of at least some events that are going on here on earth. Revelation 6:9 speaks about the martyrs, those who died for their faith in Christ, asleep under the altar in the kingdom of heaven. And they are aware of what's going on the face of the earth. And basically they say to the Lord, do you see all the evil that's going on the face of the earth? When are you going to act and put a stop to it? And Jesus' reply is, remain under the altar a little longer, keep observing, because you're going to see more people come to faith in Christ. Basically it says the work of redemption is not yet finished. There will be others that will come to faith in Christ. Be patient.
Okay, online we have a question from Craig McMahon. In a thorium reactor, what provides the neutrons to convert thorium-232 to uranium-233? In other words, what is the Kickstarter?
Yeah, good question. As I've mentioned in some of my talks, and I hinted at it in at least one edition of Weathering Climate Change, is that thorium nuclear reactors could solve the energy problems we humans are facing. And thorium nuclear reactors have a lot of advantages that uranium nuclear reactors do not. And the thorium nuclear reactors that are being proposed as a cheap source of reliable and safe energy are breeder reactors. And you've probably heard that there are uranium reactors that are breeders, where you basically use the uranium to produce another radiometric decay product and let that decay. So you're basically using the thorium-232 to make uranium-233. And it's the heat from the decay of uranium-233 that produces the energy. So you're not really getting the energy from uranium-232 for good reason. It's got a half-life of 14.1 billion years. So yeah, you do get heat from thorium-232, but not enough to be a source of energy for human use. But what they do is they use the thorium-232, you bombard it with neutrons, you make the thorium-233, which has a very short half-life, which means you get a lot of energy out of the decay of uranium-233. And because uranium-233 has a short half-life, it's a much safer breeder reactor than we get from uranium breeder reactors. And so as with uranium, the radioactive toxic waste remain dangerous for 50,000 years. With a thorium breeder reactor, you do get toxic radioactive waste, but it's way less dangerous than the waste you get from uranium, and it's safe to handle after 50 to 200 years. So that's one of the reasons why. And by the way, you get 200 times as much energy out of a thorium breeder reactor than you do out of a uranium breeder reactor. So a lot more energy, and thorium is 3 times as abundant as uranium. It's safe and cheap to mine, so I'm arguing this is a much more practical source of limitless energy compared to, say, fusion reactors. I remember when I was a teenager, the big promise was humanity is going to get all the energy it needs for a very cheap price through nuclear fusion, where they take hydrogen and fuse it to make helium. They quickly discovered that that was extremely difficult to do. The sun does it because it's got lots of gravity, but we're trying to do electromagnetic, and they said, we can't make that work, but maybe we can make the fusion of tritium and deuterium work. The problem with that is tritium is extremely dangerous, a very dangerous radioactive element. But that's what they've been working on for the past 60 years, and they still don't have an engineering pathway to make a nuclear fusion reactor. In fact, I've just written an article, it'll go up in a couple of weeks, saying, if we had spent the money we spent on nuclear fusion, trying to get a nuclear fusion reactor, on thorium nuclear reactors, we'd have all the energy we would need today for the entire world, because there really isn't a fundamental engineering barrier to thorium nuclear reactors. Okay.
Hi, Hugh. Robert Morankich. Could you speak a little bit about the interrelationship of the bulk, the great attractor, and the direction of our universe's acceleration?
Okay, I didn't quite catch the last sentence.
Any directionality of the acceleration of the universe?
Any directionality of the acceleration of the universe. Yeah, people often refer to the Big Bang as an explosion, and they use the example of, say, a bomb or a grenade exploding. It's not a good analogy, because when you pull the pin from a grenade, it explodes, but the pieces of the grenade all go out at different velocities. And so it causes damage over a significant area. With the universe, everything expands at exactly the same rate. And so instead of some pieces going out slower, other pieces going out faster, everything expands away from the cosmic creation event at exactly the same velocity. And so you do get an expanding shell, if you like, but everything is in the shell. There's nothing interior to it or exterior to it, and the thickness of the shell basically has no measure of dimension. Now, unlike a grenade, the shell that's expanding outward, it's not talking a two-dimensional surface, but it's a three-dimensional surface. So, and it's not chaotic. I mean, people often think of the Big Bang in disparaging terms because they see it as an explosion. Actually, the expansion is extremely fine-tuned. It's tuned to within 1 part in 10 to the 56th power. And everything's expanding at exactly the same rate. So we're all equidistant from the point of the explosion.
Not accelerating.
It is accelerating. So the expansion of the universe is now expanding. Now there's two factors that control the expansion of the universe. One is gravity, which works to slow it down. And so the Andromeda galaxy and the Milky Way galaxy, they attract one another. And that attraction actually slows down the expansion of the universe. What speeds up the expansion is dark energy. And so as the universe, in the surface of the universe is dark energy. And the greater the surface area of the universe, the more powerful dark energy is to accelerate the expansion of the universe. And so when the universe is young, gravity dominates dark energy because the bits and pieces of matter are close together. But as the universe continues to expand, gravity gets progressively weaker and weaker in its capacity to slow down the expansion of the universe. Whereas dark energy is the opposite. As the universe gets older and bigger, it becomes stronger and stronger in its capacity to accelerate the expansion of the universe. And so for roughly the last 7 billion years, the expansion rate's been accelerating. And the rate of acceleration gets greater and greater every year that goes by. So in 2023, the universe will expand more rapidly than it did in 2022. And in 2024, it's going to expand more rapidly than it did in 2023. And there's some models of the universe that say if we project out into the future, the universe will expand so rapidly, it'll tear apart all the particles. If you want to read about that in detail, I have an article on our website at reasons.org. I think it's titled, Giving a Rip for the Big Rip. And the Big Rip is where you got the universe expanding so rapidly that even the particles get destroyed. Not all models of the universe say that'll happen, but that will happen. We do know the universe will expand more rapidly as time goes on. The rate of acceleration is still being determined.
I know all this. My question is really regarding, is there any prejudice towards the bulk? Can you speak on the bulk?
What do you mean by the bulk?
I believe that's a term I've read regarding the great attractor.
Ah, okay. Yeah, you'll find a couple of chapters in Design to the Core where I talk about that bulk, what we call regions where we're being attracted towards. And what's made it difficult for astronomers is that, yes, we're being pulled towards what's called the great attractor, but it's in the plane of our galaxy. And that's where measurements are really difficult to make, because the stuff in the plane of our galaxy impedes our capacity to measure massive bodies more distant. But a lot of progress has been made in the last 3 years. And we now know that we're being pulled in a particular direction to an accuracy of about plus or minus 5 degrees. And we know that we're being pulled to something called the great attractor. But beyond that, way beyond that, we're also being pulled by something called the monster attractor. And we can actually see this in the cosmic microwave background radiation. You can see that there's a dipole distortion, which is basically the net result is that our local region of space is being locally pulled towards this monster attractor. Now, that's just us. Other regions of the universe are being pulled and pushed in different directions. The whole universe as a whole is expanding at a constant rate. Astronomers refer to the difference as the cosmic expansion velocity and what they call the peculiar velocity. The peculiar velocity is the velocity of the movement of a galaxy as a result of being pulled or pushed by other galaxies or massive supergalaxy clusters. And so how we map supergalaxy clusters is we remove the expansion of the universe velocity and look what's left over. Now again, the measurements are difficult to make because once you get at distances beyond, say, the Virgo cluster, the expansion of the universe completely dominates the peculiar velocities. Peculiar velocities are easy to measure within a few million light years. Once you get past 100 million light years, they become very difficult to measure because of the fact that the expansion velocity is so much greater. But you'll see a whole chapter on that in Design to the Core. Yes?
Okay. Susan has another question here. Do any other religions besides Christianity or any secular sources hold to human exceptionalism?
Okay, do any other religions hold to human exceptionalism? Islam does, but I refer to Islam and Mormonism as a Christian cult in the sense that they are based on the Bible, but they add other revelations to it. And so in Christianity, we have the Old New Testament. In Islam, you got the Old New Testament plus the Quran. In Mormonism, you got the Old New Testament plus 3 other books. So we shouldn't be surprised that there's similarities. So sometimes I make a reference to the Bible-based religions, which would include these cults that are based on the Bible. And so, yeah, in Islam, there is the belief that we humans are exceptional. But their doctrine of human exceptionalism is not identical to the doctrine of human exceptionalism we see in Christianity. And likewise, we can see a difference between what the Latter-day Saints teach on human exceptionalism and what we see in conservative Christianity. But there's a lot of similarity. Whereas what you see, say, in Hinduism and Buddhism is really different. In the Eastern religions, it's the idea, hey, we're all part of this God concept. And so there's a pantheistic belief, which is very different from what the Bible teaches on human exceptionalism. We'll be getting into those details next week. Okay, Steve.
Hi, Hugh. On human exceptionalism, it's a little bit different than the anthropic principle, but it has some overlapping principles. Human exceptionalism being that humans, are really different than the other animals. And the comment was made that are all animals exceptional, which is an interesting way to think about it. As you know, I like evolution because I think that it's progressively, I like it because of the vocabulary in Genesis 1 that it's progressively bringing from very simple life to very complex life, all interconnected, and the vocabulary, I think, shows that. But I'm open to intervention. And I know for exceptionalism and for animals, intervention can be hard to narrow down sometimes. And do you have any way to narrow that down? And if so, how do you do that?
Yeah, good question, Steve. And I think we can go to the biblical text where you see the word bara. There we've got something that's truly exceptional. And with respect to life, we only see that word used twice. It's used for the nephesh, or the soulish animals. So the Bible is making an explicit statement that the soulish animals are exceptional compared to all other life that we see here on planet Earth. And then last of all, it uses the word bara to create something brand new that didn't exist before for us human beings. So it's basically making the declaration, yes, we share a lot in common with these soulish animals, but there's something distinct in us relative to those animals, just like there's something distinct in those animals relative to all their life. And so from a biblical perspective, birds and mammals are in a distinct category relative to the microbes and the plants. There's something different about these animals. And the Bible is basically making the statements that relationally is where they are exceptional. And, what's interesting about those animals is that they're able to have emotional bonds with one another. They sacrifice for one another. They serve and please one another. But they're also designed to relate to and serve and please a higher species. But what we notice is they have no God concept. We'll be getting into this next week. We humans have a God concept. And even atheists have a God concept in that they seem compelled to argue against the existence of God. When dogs and cats and cows get together, we have no evidence that they're debating the existence of God. It's something that just never occurs to them. Evidently, they're not endowed with that capacity, that exceptional capacity to address those issues. But we're going to get into a couple of dozen ways that we humans are exceptional relative to those life. But you make a good point. Those creatures are also exceptional in their unique ways.
What I'd like to focus on, you have two baras, and I consider bara to separate, not something new necessarily, but it can bring something new about, but it's to separate usually a space throughout the Bible and all its exegesis. But to narrow this down, two baras for living things, do you think there's two interventions or unlimited number of interventions, or where do you come in between, and how do you arrive at that?
Yeah, good point. We see the word bara just 3 times in Genesis 1. When God creates the universe, when he creates the soulish animals, when he creates his human beings. But also uses the word asa, where God makes, and has a connotation of manufacture. And that's intervention in the same way that a hurricane going through an iron ore deposit is not going to produce an automobile. It takes intelligent agency, us human beings going into that ore field, to manufacture and put together that car. So I would look at that as intervention in the same way as God creating something brand new. By the way, I take on that question of separation because that is a major debate going on in the theological community. Is the word bara, is it used in the creation text talking about separation or making something brand new. I've actually got a whole chapter on that in the book that's going to be coming out next year. It's a very interesting debate. If you want the sources on, I can give you the sources.
I wrote a paper on that, and I think you read it, and you said you agreed with it. So if you have a difference from my paper of separation, which was a full exegesis...
Well, you're not taking a position like I see some of the other theologians taking, where they say the word only means separate. It never means create. And they're actually arguing that we have to stop translating the word bara as create anywhere within the Bible. I don't see you going to that extreme.
I do. It's not an extreme, but it is to separate like the heavens and the earth are separated. Heavens came first, earth came next. They were separated. It's part of the creation story, but it also profusely throughout the Bible is not a creation word. David says, separate in me a clean heart. That's bara. And so anyway, if you have that paper, get back to me, because it is exclusively different than the word create, though it's involved in creation. But thank you for your intervention and your idea on a saw.
Okay.
Yeah.
You are out of time.
All right.
You could lead us in a prayer.
I'd be happy to do that. Father in heaven, we thank you that we have the privilege of living in the 21st century. When you're revealing so much through your book of nature that complements what you've revealed in the book of Scripture. I pray that you would give us the wisdom, the humility, and the grace to comprehend what you've revealed to us in the book of Scripture and the book of nature. Make all of us theologians. Make all of us scientists. And fill us with joy as we begin to comprehend and understand what you're revealing to us. And help us to teach and instruct one another. In Jesus' name, amen.